Hey guys, happy Monday. So today we're going to be going over section 6 of chapter 7. This is the last section of chapter 7, which means that the assessment for chapter 7 will be coming up soon. So today we're going to do section 6. Wednesday and Friday will be review for chapter 7, and then Monday you will take the assessment for chapter 7, but I'll give you more information on that on Wednesday. So before we get started with section 6, let's start with the problem of the day. So solve the following: 3 raised to the x minus 4 power plus 2 equals 4. First thing we want to do is get our constants to the same side. So we're going to subtract 2 from both sides. And when we subtract 2, we're left with 3 raised to the x minus 4 power equals 2. So now we have an exponential equation, but we're not able to get our bases to the same by simplifying. If you're not able to do that, we know that we take the logarithm of both sides. So log of 3 raised to the x minus 4 power equals the log of 2. So to solve, first we want to get our variable out of the exponent. So using the power rule, that's going to come down to the front of this expression. So we have x minus 4 log of 3 equals log of 2. From here, we want to isolate our variable. So to get x minus 4 by itself, we're going to divide both sides by log of 3. And we're left with x minus 4 equals log 2 over log 3. Last step here to isolate x, we're going to add 4 to both sides. So we have x equals log 2 over log 3 plus 4. So that's fully simplified. If you would like to simplify further, you can plug this into your calculators, but this is acceptable for this one. So moving on to section 6. In section 6, we're going to talk about natural logarithms. And our objectives for section 6 are to evaluate and simplify natural logarithmic expressions and to solve equations using natural logarithms. This section is going to be split up into 2 videos. So the first part of the video is going to be simplifying. The second part of the video is going to be solving. The function y equals e raised to the x power has an inverse, which is the natural logarithmic function. The natural logarithmic function is y equals log base e of x, or y equals the natural log of x. So we write the natural log anytime we're taking the log with a base of e. So anytime you see ln, you always know that the base has to be e. So we can write it like this. Essential understanding for this section: the functions y equals e raised to the x power and y equals the natural log of x are inverse functions. Just as before, this means that if a equals e raised to the b power, then b equals the natural log of a, and vice versa. Since the natural logarithm is still a logarithmic function, all the properties of logarithms also apply to natural logarithms. So the only difference between logarithms and natural logarithms are that natural logarithms have a base of e, so we still use the same properties to simplify natural logarithms. So let's look at some examples. First example: what is 2 natural log of 15 minus the natural log of 75 written as a single natural logarithm? So we're going to use the same properties that we've been using, power rule, product rule, quotient rule, to write these as a single logarithm. So first thing, in our first term, we have 2 natural log of 15. This 2, using the power rule, can become our exponent. So we have the natural log of 15 squared minus the natural log of 75. We can simplify 15 squared to the natural log of 225 minus the natural log of 75. Next, using the quotient rule, we can write this as the natural log of 225 divided by 75. So we do have a single logarithm, but this is not fully simplified. To fully simplified, we have to divide. So our final answer is going to be the natural log of 3. A couple more examples for simplifying natural logs. What is each expression written as a single natural logarithm? For A, we have 2 times the natural log of x minus the natural log of y plus the natural log of 5. And B, 3 natural log of x minus 2 natural log of 2x. So if you want to try these on your own, pause the video now. If not, we'll get started. So for A, we have 2 natural log of x minus the natural log of y. We're going to distribute this 2 to both terms and rewrite it as 2 natural log of x minus 2 natural log of y plus the natural log of 5. So we've gotten rid of our parentheses. Next, using the power rule, this 2 becomes an exponent and this 2 becomes an exponent. So this becomes the natural log of x squared minus the natural log of y squared plus the natural log of 5. Next, we're able to rewrite our first 2 terms using the quotient rule. So this becomes the natural log of x squared over y squared plus the natural log of 5. Finally, we can simplify using the product rule to the natural log of, because this is the product rule, that means we're multiplying 5 to this fraction, so 5 will be on our numerator. So we have 5x squared over y squared, and this is fully simplified to 1 natural logarithm. And for B, we have 3 natural log of x minus 2 natural log of 2x. So by the power rule, 3 becomes our exponent and 2 becomes our exponent. So when we rewrite, we have the natural log of x cubed minus the natural log of 2x squared. First, we're going to simplify 2x squared. So we have the natural log of x cubed minus the natural log of 4x squared. Don't forget that exponent goes to every term in your parentheses. Next, we can rewrite using the quotient rule. So we have the natural log of x cubed over 4x squared. So now we have a single natural logarithm, but we can simplify further because both terms have x. When we simplify, we have the natural log of x over 4. And that's our final answer, fully simplified. So that's for simplifying natural logarithms. You use the same rules as you would for any other logarithm. You can use the inverse relationship between y equals the natural log of x and y equals e raised to the x power to solve certain logarithmic and exponential equations. So let's look at some examples for solving a natural logarithmic equation. First example, what are the solutions of the natural log of x minus 3 squared equals 4? So remember, for these, we're using the rule of the definition of logarithm, which is the natural log of x equals y, if and only if x equals e raised to the y power. So we're going to rewrite this logarithmic equation in exponential form. So we have to be able to identify our x and our y. In this expression, our x is going to be x minus 3 squared, and y is going to be 4. So when we rewrite this in exponential form, we have x minus 3 squared equals e raised to the 4th power. So when you're rewriting this, you're dropping your natural log, and your constant becomes the exponent for e. Now, once we have it in exponential form, we can simplify and solve. So x minus 3 squared, first thing we're going to do to get rid of that exponent is take the square root of both sides. When we take the square root, we have x minus 3 equals plus or minus square root of e raised to the 4th power is e squared. So don't forget this plus or minus. Next step, to isolate x, we're just going to add 3 to both sides. When we do that, we get x equals 3 plus or minus e squared. So this equation has 2 answers. One is 3 plus e squared, and the other is 3 minus e squared. The last 3 problems for this video. What are the solutions of each equation? Check your answers. So for A, we have the natural log of 2x plus the natural log of 3 equals 2. Before we can change this to exponential form, we have to simplify this to one natural log. Using the product rule, we get the natural log of 6x equals 2. Now to rewrite this in exponential form, remember that anytime you have the natural log, that means our base is e. So e raised to the second power equals 6x. So we have 6x equals e squared. So you can think about it either way. You drop the natural log, so we're just left with 6x, and your y becomes the exponent, or you can use this little cycle that we've been using for some of our logarithmic equations. You'll get the same thing either way. So we have 6x equals e squared. To solve for x, we're just going to divide both sides by 6. And we have x equals e squared over 6. If you plug that into your calculator, you're going to get approximately 1.232 for your final answer, and you can check that by plugging back in for your variable. For B, we have the natural log of 3x plus 5 squared equals 4. In exponential form, this is going to become 3x plus 5 squared equals e raised to the 4th power. To solve for x, we're first going to take the square root of both sides to get rid of our exponent. So we have 3x plus 5 equals plus or minus e squared. To get x by itself, next we're going to subtract 5 from both sides. So we have 3x equals negative 5 plus or minus e squared. Last step to isolate x, divide both sides by 3. So x equals negative 5 plus or minus e squared all over 3. So this equation has two solutions. One is negative 5 plus e squared over 3. The other is negative 5 minus e squared over 3. And for C, we have the natural log of x plus 9 over 3 equals 8. In exponential form, this is going to become x plus 9 over 3 equals e raised to the 8th power. So to solve for x, the first thing we have to do is get rid of this 3 in the denominator. So we're going to multiply both sides by 3. And this becomes x plus 9 equals 3e to the 8th power. Last step to solve for x, we're going to subtract 9 from both sides. So x equals 3e raised to the 8th power minus 9. And now we've isolated x, so this is our solution. That's it for this video. In the next video, we're going to be finishing section 7, which is also the end of chapter 7, and we're going to go over solving an exponential equation.